All right, good morning, everyone. Welcome. Great to see everyone back again. We're going to give everyone just a minute to get in uh, to the call, and then we're going to go ahead and get started right at the top of the hour, as we have quite a bit to cover today. So again, welcome, everyone joining us. Hope it's relatively cool and comfortable wherever you are. You know those locations are few and far between these days, so. All right. Still people joining from the waiting room, but we are going to go ahead and kick off. We have quite a bit to cover. We have some potential Wi-Fi instability, so want to make sure we get through as much as we can while everyone's here. So again, welcome. Thank you for joining us for this morning's press briefing, where we will be covering updates from our July 2026 temperature update. So we'll go ahead and do some quick introductions first. Next slide, Robert. For those of you who may not be familiar with Berkeley Earth, again, welcome. Thank you for joining us. We're a small nonprofit based in California, but we are global at this time. I'm Kristen Sissener. I'm Executive Director of the organization, and I'm joined this morning by Robert Rohde, our Chief Scientist, Zeke Hausfather, Research Scientist, and also Kate Viscara, who keeps everything running behind the scenes, and we're grateful to have her support as well. Next slide. Just a quick note before we jump into the report, but the vast majority of the analysis that you will be seeing today is based on Berkeley Earth's own high resolution observational temperature record. And there's some information about that here. Kate is going to go ahead and drop the link to the request form in the chat. So if you're interested in accessing this data set, you can do so through that form. Again, we have full global coverage at a quarter degree of resolution. We also have off-the-shelf subsets available for over 8,000 global cities. And if you jump to the next slide, all of our full observational record is now also available on our new platform, Synthesis, and the link to access is on the screen as well as in the chat. Thank you, Kate. This platform provides access not only to our full observational record, but we now also have city level projections available for more than 8,000 cities across all 5 SSPs. There's also, for a select number of cities, there are a suite of derived metrics, including days above 35°C, annual max and cooling degree days. Additional cities and additional metrics are available on request, and we do also offer commercial licenses for those who are interested in working with this product in their own products. Just a couple quick housekeeping notes before I pass to Robert to get into the report. We are recording this call, and the recording as well as the slides will be sent out after the call. We also will be taking Q&A as usual after the presentation is complete, and feel free to go ahead and pop any questions you have in the Q&A box as we go. We will try to get to as many of those as we can before the end of the half hour. And I think that's it for housekeeping. So I will go ahead and pass to Robert to get into the update.
Okay, so hello everyone. Glad to have you today. So we'll be talking primarily about temperatures in July as it relates to global climate and the outlook for sort of the rest of the year. So some top line things. July was the second warmest July on record in the Berkeley Earth analysis. It was the first month of 2026 above 1.5. Oceans were nominally the second warmest. Land was nominally the third warmest. We'll talk a little bit more about these in a little bit. We're currently experiencing a rapidly strengthening El Nino that is expected to become the strongest El Nino on record later this year. So we will devote some time to this. Obviously, the recent heat has had various effects across Europe and North America. It's been a very hot time lately. The odds of a record warm temperatures in 2026 have jumped up remarkably as El Nino has materialized, and I'll highlight that at the end. Okay, so to show you a little bit where we are. So this is July monthly averages across the globe. The 2026 value lies in between 2023 and 2024. It's basically tied with 2024, but noticeably less than still, no, still noticeably less than 2023. Um, it's the first month of this year that pushed above the 1.5 threshold. That is the sort of the canonical benchmark that the Paris Agreement. And the last 12 months are sitting at the third warmest, year to date. Well, not year to date. Last 12 month period is third warmest such 12-month period. Okay, so this now shows for each month of the year, and each curve is a different year, showing where we lie in 2026. So July 2026 was the warmest month of this year so far. It's following very much at the top of our scale, but just below records from previous years. So it's, this case, July was second place behind 2023. We've been spent most of the year sort of flirting with the sort of second, third, or fourth place. So we have not had any months so far that have been record warm on their own, but we're still staying at the top of scale, expecting to be one of the hottest years on record. And with the development of what is likely to be the strongest El Nino in the history of human measurement, these numbers are likely to push up and probably be above the previous record soon. And we think it's now likely, more likely than not, that there's enough warmth generated by an extraordinary El Nino event that we could have a record warmth in 2026 and much stronger warmth in 2027. Okay, so looking now specifically at 2026, you can already see the signature of a very strong El Nino event in the Pacific, complete with strong warming along the South American coast, extending into the Central Pacific. We also had considerable warmth across Western Europe, which I'm sure many people have seen in the news, as well as heat waves affecting North America and widespread heat across Central and Eastern Asia and parts of Africa. The only place that's been significantly cool in July was in Antarctica, where it's currently Antarctic winter, and it's been a very, very cold Antarctic winter this particular year. Looking at temperature anomalies, but where it's been record warm and cold, you can see that the Central Pacific has been record warm or near record warmth across large portions of the Central Pacific, extending also into coastal South America. This is the signature of what is likely to be a record-breaking El Nino developing in the Central Pacific. There's also warmth across Africa, significant warmth in Asia, Western Europe, little patches of extending into the North Atlantic. But about 0.5% of Earth's surface was set a record for local July average, including 6% of land and 9.8% of ocean, which is an unusually large share to be setting a record in a given month, and larger than in June. Near record cold temperatures were observed in parts of Antarctica in July. So unusual, but it does happen from time to time with this very cold winter that they are currently experiencing. In terms of where records are occurring, we estimate that 32 countries set new records for their national average temperature during July. That includes a number of countries in Western Europe, Africa, South America, but also includes the United States, which I wanted to highlight in particular. So this chart shown here is for the contiguous United States, so just the lower 48 states. It's also a record for the entire United States, but I chose the contiguous United States in this case because I wanted to compare it to NOAA data as well. So Berkeley Earth is shown in blue, NOAA is shown in green. And both of our records have July 2026 as the warmest July on record, and in fact, the warmest month of any kind on record. So not also beating June and August average past. This is particularly because up till this point, NOAA has had July 1936 as their warmest national average month. So that was the middle of the Dust Bowl. There are still many records at weather stations and many state records that come from the 1930s during this, extraordinary Dust Bowl event, which was also partially man-made because of agricultural issues, poor agricultural practices. But it was a very localized event specific to the United States, has had a large signature on historical records. And we are now pushing beyond that in the weather conditions that we are getting in the United States. And I would also note that this fluctuation is not very far above trend. It's record warmth for July, but there certainly have been many Julys that were much larger deviations from trend than this one. Whereas the trend has moved up quite strongly in the United States over the last 50 years or so. And that's something we've seen in a lot of places that the last 40, 50 years have seen very rapid warming. One other location I would highlight, due to the context of recent heat waves, we had recent heat in June and July centered over France. Unsurprisingly, France set a national average record for July, beat the previous record by about half a degree Celsius, which is a relatively large margin in these things. But it's consistent with the long-term warming trend we are seeing in France, which is quite rapid. We've seen, 2.5 degrees in the July average over the last, 40, 50 years. And I'll also note that this chart goes back to 1750. This is European. European sites are among the oldest places where weather data has been collected. So in France in particular, and Western Europe in general, there's weather data that goes back farther than anywhere else in the world. And yet this July is standing out as the warmest that has ever been observed in France. Okay, so turning back to global pictures, land temps. Sorry, this is a chart of ocean temperatures for July. It's nominally the second warmest. It's essentially tied with for first warmest with 2023, but just slightly below. Some other records, particularly the Copernicus, looks at 60 south to 60 north, and they have it the warmest in that band. We actually average the whole ocean, and that's causes us to be a little bit lower than them. That's why we're second place instead of first place. But ocean heat has been climbing steadily. Land has been lagging behind a little bit. It's only the third warmest on July on land, which I'll show a bit more in a moment. I would note that we have been rapidly rising the ocean average temperature the last several months since the La Niña ended at the beginning of the year. We've had a rapid warming in ocean average temperature. Currently, we are sitting on the third warmest monthly anomaly on record, second warmest July, third warmest of any month. And we're expected to move higher with the El Nino developing. So we will soon be moving into record warm ocean territory over the next few months. Okay, so this is now, so this is the seasonal chart. So it's the last 3-month period. So it's not really a season, it's May, June, July. But the last 3 months is the second warmest on record. The first 7 months of 2026 were also second warmest, and the oceans were the second warmest for the first 7 months. So let me talk a little bit about impacts. We're not going to spend a great deal of time on this in this particular monthly briefing, but we've seen heat waves affecting Western Europe, affecting the United States. It has been followed in many cases by wildfire affecting France, Spain, the Western US and Canada have all seen significant wildfires following periods of intense heat and drought. And that's what you usually find that, heat and drought precedes wildfire activity that gets particularly extreme. Uh, the heat waves themselves have set many records. The wildfires have been disruptive. Many people in North America will remember smoke coming down from Canada, blanking parts of the US. Uh, Early estimates suggest approximately 20,000 people have died during the heat waves in Europe this summer. And other places have seen significant evacuations from wildfires or from other effects of this extreme weather. Okay, now we will talk a little bit about El Nino and where we're going with the conditions in the Pacific. Hopefully Zeke's Wi-Fi is working for him, or otherwise I will present the slides.
Yeah, let me know if it works. Just for context, I'm in Mexico City for a intergovernmental panel on climate change lead authors meeting, and unfortunately, the hotel Wi-Fi is not the best. So the chart here shows this year's El Nino event in terms of anomalies of temperature in the Niño 3.4 region of the tropical Pacific. Red is the 2026 temperatures, and then what is also highlighted here are the previous two of the previous strongest El Nino events. 1997, 1998, and 2015 and 2016 in green and blue, respectively. And there's a few remarkable things here. One is that we are already above any daily temperatures experienced during the 1997-1998 El Nino event, even though it is only early August. And while we still haven't passed the records set in 2015-2016, which is tied with 1877-1878 as the strongest El Nino event in recorded history, we are already close to the peak temperatures during 2015, well in advance of the peak of the event itself. So El Nino almost always peaks in the northern hemispheric winter months, generally as early as October, but mostly between November, December, and occasionally as late as January. And so we have many months to go while this event continues to develop. And that's one of the reasons that we have increased confidence that this will be a record-setting event. And it already is in sort of very strong or super El Nino territory this year. So next slide. So there's 14 different modeling groups around the world that provide what we call dynamical models of El Nino development. These are essentially weather and climate models that simulate what's going to happen to ocean temperatures and atmospheric dynamics over the remainder of the year. And these models have consistently produced higher and higher forecasts as the year has advanced. So the latest version of all these models that came out in early August, so actually 3 days ago, is the most recent tranche from the Copernicus C3S system, are now projecting a peak El Nino event this year of about 4C in the Niño 3.4 region. For reference, the strongest on record prior to this year was 2.75C, but there still is a reasonable spread across the models. There's one model, the Syntax F model from Japan, that is still running a little on the cool side, though it is noteworthy that its forecast of the peak is lower than the current observed sea surface temperatures in the Niño 3.4 region, so I might discount it slightly because of that. It also has yet to update through August, though the rest of these models have an August run. It's still based on its July run. All the rest of the models for the UK Met Office, NCAR, the various Canadian models, Germany, France, Australia, Japanese Meteorological Agency, ECMWF in Europe, NOAA, NASA, NCAR, etc., are all projecting a record event. And so across all of these models, we see about a 96% chance that this year will be the strongest El Nino on record since 1850 at least, and potentially the strongest El Nino if it ends up peaking around 4C and much, much longer. We don't have great paleoclimate records of El Nino strength, but it's not beyond the realm of possibility to say that this might be the strongest El Nino event in 500 or even 1,000 years. And there's also increasing likelihood that El Nino is going to persist into the Northern Hemisphere spring in 2027. And that will lead to it carrying significant warmth into next year. Next slide. Next slide, Rob. There we go. So in terms of the effect of El Nino on surface temperatures, we have historically seen a bit of a lag between when El Nino peaks and when the maximum global surface temperature impact of the El Nino event is. And so this plot shows sort of the months from the El Nino peak across 10 strong El Nino events in the historical period. And the blue line is the global temperature response. And so right around 3 to 5 months after El Nino peaks, we see the biggest response. A strong El Nino event, which is anything above 1.5 C in the tropical Pacific, is usually associated with a elevated global temperatures around 0.2 C for 3 to 5 months. Very strong events, above 2 C, are associated with elevated temperatures closer to 0.4 C for that period. And then obviously for this event, which is off the scale, we don't know entirely what the effect is going to be because we've never experienced an event this strong. So it's out of sample, so to speak, but we would expect the global surface temperature effect to be even stronger than any previous El Nino we've seen. And so for that reason, we'll show you later some predictions of this, but we are increasingly confident that 2027 will be a record warm year. And maybe, as Robert noted, 2026 will be a record warm year as well, simply because El Nino is developing so quickly that its effects on the remaining half of the year will be much stronger than in a typical El Nino event that doesn't develop until later in the fall. Next slide. So El Nino has a number of different effects on the climate system. There are a few that are more deterministic than others. Some of the stronger and more clear impacts are increased rainfall in the El Nino tongue, and decreased rainfall outside of the El Nino tongue, so the area surrounding it, as well as to the east of the El Nino tongue, so areas like Southeast Asia, northern Brazil and the Amazon, southern Australia, southern Africa, India. These are all expected to be considerably drier than normal, which can have significant implications, and hotter than normal, which can have significant implications on agricultural systems. And in fact, some of the biggest damages from previous El Nino events have been associated with crop failures in those regions. We expect, the southern US to be wetter than normal, including the West Coast. And, other regions, there's less clear-cut effects, but in general, El Nino tends to cause a lot of anomalous weather worldwide. Next slide. So in terms of broader impacts, and we covered this a little bit in last month's briefing, but regions that are drier include Indonesia and Southeast Asia, Eastern Australia, Southern Africa, and Northern Amazon. In fact, there's recently a piece in Nature about how the Amazon could be particularly susceptible to fires this year because it's already recovering from the 2024 El Nino, and this is happening in quick succession. A weaker Indian monsoon is quite possible. Certain regions will be wetter. We expect fewer Atlantic hurricanes, but more Eastern Pacific cyclones. We expect widespread coral bleaching across much of the tropics, given high sea surface temperatures, as well as disrupted fisheries. And then, overall warmer 2026 and 2027 with increased likelihood of record years. So next slide. Okay, I'll turn it over to Robert to talk about said record years.
Okay. Yeah. So we forecast the likelihood of a record and what we expect for the rest of the year, how 2026 should play out. Right now 2026 is roughly speaking aligned with the third warmest year on record. We have had no months of 2026 that have set a record high. However, the developing El Nino is going to change the calculus a lot, and the models that we have been using have finally decided to dial into the fact that this could be a really extraordinary event. Up to this point, they've basically been arguing that we don't yet see the warming in the Pacific enough, and the forecasts are so extreme that it seemed somewhat implausible. So the statistical models were sort of semi-rejecting what the El Nino models were telling us. But that has changed now that we have very strong conditions already developing in the Pacific. And the forecast is jumping up dramatically. Last month, we put a 12% chance that 2026 would warm enough to get to be record warm. Now the forecast is saying that there's a 69% chance. So there's, more likely than not, the rest of the year is so warm that it pulls the average above 2024 and manages to set a record warmth in 2026, probably by a small margin if it does so. It's almost certain that we will receive 1.5C this year. Interestingly, I would note that the forecast already says that there's a 99% likelihood that the oceans have a record warm year. What's lagging behind quite a bit is the land, that the land is still unlikely to be record warm, and that is pulling down the average for the year. But if this develops into what is, in some sense, a shockingly large El Nino event, then it may have a decent chance of getting to record warmth even this year. Here's another way of presenting that. 69% of chance of warmest, 30% chance of second warmest, then it's small chance of anything else. Right now, the 12-month moving average is sitting close to the trend line. So there's a lot of pulling up that needs to happen to get to first place. But the forecast is that extreme that it thinks it's possible. In fact, more likely than not. El Nino events are the main source of interannual variability. The short-term fluctuations are mostly El Nino events. Some, chance for volcanoes, some, variations for other parts of the world. But El Ninos give us a lot of the short-term wiggles. And the long-term trend has been going up. It's not yet crossed 1.5, but it's going to cross it very soon, especially if we're pulling up by, having another strong El Nino another record-breaking El Nino after the significant El Nino we just came out of. And this is setting, as Zeke already alluded to, it's setting up 2027 to be a monster year. The warmth coming out of, almost ridiculously strong El Nino, assuming the forecasts are correct, should push 2027 up to be a clear record-breaking year. We get perhaps we get a little bit of a record in 2026, but 2027 seems positioned to smash it, with all the warmth from El Nino this winter being pushed forward into the year. So we're likely to see something quite dramatic the next year or so. It will be telling us about the weather that it will be giving us weather conditions that we would normally expect to be a decade or more away. But it's going to be a big deal. Okay, so thank you for listening to the presentation. I think we will open it up for questions in just a moment.